Hi, my name is Brittany Evans. I'm reporting my action research findings on using science books insightfully to support and assess scientific observations in elementary classrooms. I attended Millerville University for assessment, curriculum, and instruction with a STEM concentration. I teach in Northern York County School District at Northern Elementary in first grade. Integration of skills across disciplines has been a repeating topic of discussion throughout my graduate studies and within my district for the past several years. In order to connect my studies, my instruction, and my passion for writing and science, I decided to base my action research on the implementation of science notebooks within my first grade classroom. The purpose of the study is to assess the impact of science notebooks on first graders' ability to make scientific observations and inferences within an air and weather science unit. This research allowed me to coherently merge informational writing skills required by the Pennsylvania Common Core standards with science learning as laid out by the next generation science standards. The integration of skills has improved the accuracy of students' scientific observations and challenged students to develop inferences within their written explanations, transforming first graders into true scientists. For this I had multiple research questions. How does the use of science notebooks over the duration of an air and weather unit impact student observation skills? What types of scientific observations do students communicate in their journal? What types of scientific observations are challenging for students? And how do written scientific observations relate to student science learning? A fundamental yet challenging skill for young scientists is observation. These observations will often serve as evidence in the scientific arguments, explanations, and theories of the field, according to Aris and Davis. Students and teachers must be aware of the key features highlighted by Aris and Davis for scientific observations. These include being clear, complete, accurate, objective, and use scientific vocabulary. Recording quality observations in science notebooks has the potential to be one rich source of formative assessment data about student scientific thinking and practice in the science classroom, according to Shelton. As with each assessment practice, however, teachers must be aware of its capabilities and limits. Shepherdson and Birch warn, as teachers we must be careful not to confuse learning the activity with learning the science when assessing students' conceptual understandings through notebook entries. Teachers encourage and guide students to move beyond learning the activity to learning the science as they ask why versus what. Ashford and Alonzo show the importance of teacher responsibility as they examine the use of science notebooks to monitor students' observations and conceptual understanding. The researchers found that too much teacher guidance led to copying notes and overestimation of student understanding, whereas too little guidance led to poor or unclear student work and the potential to underestimate student understanding. I implemented the FOSS Air and Weather unit, which consisted of 5 activities from the third investigation, focusing on wind over a 3-week time period. I integrated science notebooks using a rubric log as assessment, which guided conferences with students and allowed me to conduct interviews when student learning was unclear. I concluded with the FOSS iCheck assessment, allowing students to use their notebooks as a source of reference for this unit. iCheck, a scientific assessment built within the FOSS curriculum, allowed the students to use the information in the notebooks to push their understanding of scientific content further, according to Fulton. In order to assess observation and inferences within the notebook entries, I generated a log rubric combining the notebook assessment log, if you look on your Appendix B that you were given, and the rubric for characteristics of quality observation. If you refer to Appendix C, you'll see how I generated my own notebook log rubric. Students communicated both graphic and written scientific observations. However, the depth of their science learning varied between the two. Process learning was demonstrated most frequently through students' graphics. Interviews were conducted when students' observations needed further explanation in order to assess what types of learning occurred beyond what students demonstrated in their graphic writing. As the investigations progressed, students' writing began to move from activity learning to process learning. The following themes derived from analysis of student notebook entries, interviews, and iCheck assessment. Accuracy versus the imagination. While students' graphics supported students' scientific observations to move beyond activity learning, the rubric helped highlight strengths and weaknesses within the students' graphics, one area of need being the accuracy component. Within the first investigation, one student received a proficient rating within the accuracy component, while 6 students received proficient rating with the accuracy component. The second investigation, over half the class continued to struggle. In order for scientific observation to be accurate, Arias and Davis noted that observation includes the same color, sizes, and shape as the object being observed. Again, you can look at your appendices to see their requirements. 6-year-olds are still developing as illustrators and often use their imagination to assist as they record their ideas, making people the size of trees, a rainbow of colors, and have the ability to float. But I believe that if students could more accurately represent their observations with their graphic, it would help support them more accurately write the why behind the activity, as first graders often use visuals to help scaffold their writing. I also noted the importance of establishing criteria. Following the first and second investigation, a mini lesson was conducted on how a scientist records their observations during investigation. The lesson focused on the importance of color, choice, size, and real-life awareness. We compared creative journal writing and scientific observations, deciding the appropriate context for both the illustrations. After establishing criteria, 11 students received proficient ratings within the accuracy component. An increased number of students began using writing as a model for process learning. And in the final iCheck assessment, students scored higher on the investigations that had increased accuracy and higher number of students demonstrating process learning. The third theme was the development of questions to support student inferences. While students' graphics became more accurate for the investigation 3, following the mini-lesson, their written work showed activity over process learning. What had allowed the majority of students to make inferences within investigation 1 and 2? As I began to examine the investigation focus questions, I realized the question in investigation 3, how can the pinwheels be used to observe the wind, seemed to prompt students to restate the activity versus address the science. Knowing the next investigation incorporated a second weather instrument exploring wind, the wind vane, I decided to incorporate both instruments in the prompt, compare and contrast the purposes of wind wheels and wind vanes. While the FOSS kits may have focus questions developed for each activity, I realized the importance of refining and reframing the question to encourage students to make inferences about the science process behind the activity versus the activity itself. My own learning. I realized the importance of establishing clear criteria prior to conducting the notebook journal entries. When students have received clear criteria, they understand what is being expected of them. In order to do this, I will continue to lay out the expectations as aligned by the appendices you were given. I also noted the importance of refining and reframing questions. Even though the FOSS kits come with focus questions, I realized the importance of assessing those focus questions and seeing if students really will be able to come out with the process learning from the question. My role as a teacher was really determining the amount of guidance that I was given. I realized the importance of allowing students to work independently and in small groups before conducting interviews and conferences with the students, so I could truly see what they had an understanding of prior to interactions with myself. I believe that this research could be the starting grounds of support for assessing science notebooks beyond the first grade classroom. Thank you for your time.